Hi, it's Jimmy here at Jimmy Math Tutoring, and I'm here to do a sample problem for you. Want to give you a few little sample problems so you can see me, working a math problem. Maybe like it would be in our math tutoring session. Hopefully, I would be able to work it for you well, and you would learn, something and benefit from it. But there's infinitely many kinds of problems. There's just a lot of different kinds of problems. I mean, I can't do one of every kind, but I picked, just a representative here and there. This one is, find the interval of convergence of summation summation 2 to the n x minus 2 to the 2n all over n. So that's 1 to infinity. And this is a problem that it tests a little bit of knowledge in several things. So I mean, this is like a it could be a very big stumbling block to someone, if this is their first time, seeing, all this stuff, calculus, and it builds on, your knowledge of, series, and the series tests that, were necessary, to do the problem. But, basically, if we think of this as, if we let, an equal to, this thing right here, an is going to be that. See, that's our an, and 2 to the n times x minus 2 to the 2n all over n. And what conditions, well, you have those tests. So you have to remember those tests. The the root test, the nth root test, and also there's the LCT, the limit comparison test, and limit comparison test. Those are the two ones that you would be wanting to use here, to try to find, the interval of convergence, of this, power series. It looks like a power series, So this was a problem on an exam, on a calculus exam, something like a final exam or something during the semester. I mean, it's an ideal type of problem that you're likely to see, so it's not like something I made up, it actually came off of a calculus college exam, probably, at the end of first semester, that's when you start seeing, power series and these, tests. So, I'll just go ahead and tell you, since I've worked the problem before, that either one of these, two methods will work, but I'm more inclined myself to go with the limit comparison test. That's the one I tried originally, so that's the only one I'm going to work, here. But the nth root test, works similarly. Doesn't work exactly, but it works very similarly. So, what we have to do is, let, L equal to, the limit, as n goes to infinity of absolute value of an plus 1 over an. That's what that, that's what the limit comparison test, tells you. We have to evaluate that limit, and we have to see what it equals. Well, first thing to notice is, that this is a positive quantity. An is always greater than 0, so we can just drop the absolute value and just, we can just drop the absolute value because that's everything's always positive. And So we've got this now, and that's equal to an plus 1. Well, it's 2 to the n plus 1 times x minus 2 to the 2 times n plus 1 divided by n plus 1. See, that's the n plus 1 part. And then we have to divide, on the bottom we're going to have, this factor right here. 2 to the n, x minus 2 to the 2n, and divided by n. So we have a big numerator and a big denominator. Is what we have is that, and well, we can write that, in an easier to understand fashion, so that we can, cancel some things out, so to speak. If you can't see it right here, well, let's just go, over to here, and let's take a look at what that really is. Well, it's equal to, it's equal to, as we already saw, 2 to the n plus 1 x minus 2 to the 2 times n plus 1, all over, n plus 1. And then where the trick is, this bottom denominator, we can flip it, you see, and put it as this, n over, and then 2 to the n times x minus 2 to the 2n. I mean, that's how you rewrite, the denominator. I mean, that we saw, down there. That's how you rewrite it. That's how this thing. That's how we can cancel things. Is we flip this thing upside down and put it in the numerator. That's just a typical algebra technique, and then it goes up to there, and it looks like that. You see. Well, so what's so great about this thing, Well, we can rewrite that again, We're going to move this to the over here and move this over there. So, just rewrite this as 2 to the n plus 1 times x minus 2 to the 2 times n plus 1. And then we're going to put this thing right here under there, see, so that we can start doing our canceling. This is really, it's really a very straightforward, exercise in finding the interval of convergence. I mean, there's nothing tricky about it, and it just really tests your ability to understand what a power, what the interval of convergence is, and how to apply the test. So this is not, something that you wouldn't see on an exam. You would in a college calculus class probably see something like this. So then we just put the n over n plus 1 together. That's why I moved that over there, moved that over there, and now I've got that. You see, and well, of course, I should be writing, limit, because I haven't taken the limit yet. So I should be writing the limit is n goes to infinity, limit n goes to infinity, like that. I should have also written it over here as well. But anyway, once we get here, it's like we can break it up, into two separate, limits. This part right here, one thing, and then this part right here is another thing. And my claim is, well, that part is just 1 right there. N over n plus 1, it goes to 1. And then the only question is, what is that thing? But n over n plus 1 goes to 1 as n goes to infinity. So, all we really have to worry about is this thing right here. But we can simplify that. You see, 2 to the n plus 1 over 2n, that's just 2. And then x minus 2, well, these two factors, it's the same thing. It's going to give us an x minus 2 squared. See? And then times 1. So, we still haven't taken the limit yet. Well, we actually, there's no ends left, see? There's no ends left in it, so taking the limit doesn't do anything. The answer is 2 times x minus 2 squared. So that's the answer. Now, what does that have to do with anything? Well, remember, the limit comparison test, says that has to be less than 1, for us to, have a convergence, So, less than 1, say less than 1, and solve that equation. Okay, well that means x minus 2 squared is less than 1/2, and so, take the square root of both sides, we get absolute value of x minus 2 is less than 1 over the square root of 2. So that might be tricky to you, but still, it's just straightforward, stuff. And so now we need to write this out. We need to solve for x here. So how do we solve for x? Well, you write out what the absolute value means. So let's do that up here. That means that minus 1 over the square root of 2 is less than x minus 2 is less than 1 over the square root of 2. And then we add a 2 to everything, and we get 2 minus 1 over the square root of 2 is less than x is less than 2 plus the 1 over the square root of 2. So that's like the final answer almost. It's that is part of the interval of convergence. That interval from. But the question is, you see, here's the question: is we have to test the endpoints. Because you never know. We don't know about these 2 endpoints here. The endpoints are unknown, until we test them specifically. So we know everything in that interval between those 2 endpoints is part of the interval of convergence, but we don't know yet whether the 2 endpoints are also part of the interval of convergence. So that's what we have to test it for. And so how to test? Well, you plug in the endpoints. Plug in the endpoints into the infinite series and see if it converges. Well, we already know what our series is. It's that thing, and so we have to plug in the endpoint into the value of x. So one of the endpoints is 2 plus 1 over the square root of 2. So we have to plug in that value for x and simplify it and see, does this series converge when we actually plug in that number. So that's what we have to do for both endpoints, not just one of them, but both. It actually turns out that both of them, well, we'll just see. We'll just see. So let's try, the first one. Let's plug it in. Well, then that's going to be, summation of 2 to the n times x, which is 2 minus 1 over square root of 2. So that is, our x right there in parentheses, and then minus 2, and that is to the 2n over n. And now let's simplify that. The 2's cancel, they go away. So we're just left with the 2 to the n times minus 1 over